This is lesson 6.1, and I will have 6.2 following right after this. These are your essential questions or your I can statements, what you'll be able to do. This is about higher degree polynomial functions. That's what this chapter is about. So a lot of what you've learned already in chapters 1, 2, 3, 4, 5 will apply to this chapter. I'm going to skip all of these. Let's take a look at the chart on page 422. So if you needed to get anything out, you can always pause this video. And being that we are doing this online, you will be uploading your notes that you take and homework. So you should have a notebook out right now taking notes. That's your verification that you've watched this video and that you've followed along with me. So please take notes as you go. All right, so let's just look at this graph. Some of this earlier stuff will seem pretty easier, but let's take a look at the linear first, which is like y equals mx plus b. And this one has a positive slope. As you're going to the right, it's going up. This one has a negative slope. As you're going to the right, it goes down. The degree is 1. So if you take a look at where the x to the first power is. Number of turning points is 1 less than the degree. So it doesn't turn at all. A straight line doesn't. And then end behavior, what does that look like? So the end behavior on a positive leading coefficient, when the m is positive, it is going from negative infinity and then it goes to positive infinity, it goes up. This one goes from positive infinity, goes down to negative infinity. And the degree, even or odd, this one's going to be odd because it's to the first power. Quadratic looks like these. This is a positive leading coefficient, a negative. The degree is 2, so y equals x squared would be example. Turning points would be 1, so there's a turning point there. There's a turning point there. The leading coefficient, if it was positive, that's what it looks like, versus negative. So this is the end behavior. How does it go as it goes to negative infinity? It goes up. How does it go as it goes to positive infinity? It goes up. So the ends are both up, the ends are both down on here, and it's an even degree. Next one is cubic. So we got a positive leading coefficient and a negative leading coefficient. So a positive leading coefficient looks like this graph right here, or this one. And notice the end behavior. It goes to negative infinity down here and it goes to positive infinity there. Versus the negative leading coefficient is just the opposite. And it goes from positive infinity down to negative infinity. And cubic is y equals x cubed. Has an odd exponent. It has a degree of 3. And turning points, 1, 2, or it could have 0. If it's just y equals x cubed, there is no turning point right there. That's where the 0 comes in. I just want to point that out. That is never like dipping down. It's just flattening out a little bit more and then it's going back up. So there's no turning point on that one. Okay, the next one is quartic. And quartic is to the 4th power, and it would have 1, 2, 3 turning points, or it could just have 1 right there. And positive leading coefficient versus negative, notice the endpoints, they both go up, they both go down, and it has an even exponent. Okay, so terms, let's go on this next part here. The terms equal the degree minus 1. And the a, so I'm going to put up here what this would look like here. So if we have y equals a to the x minus h, and then it would be plus k. And then whatever this is here, this could be squared, cubed to the 4th power, whatever that is. This could vary what the degree is, depending on the function. But when the a is positive or negative, so if we have an x cubed it's going to look like this. That's going to be positive, and it's going to look like this, which is going to be a negative a. So this is the x cubed one. And then if we did an x squared one, if the a is positive, this is kind of stuff that you already know, right? And if the a is negative, it looks like that. And I should have arrows on these. Okay, so let's look at the ends. Kind of went over that chart really thoroughly on purpose. So if I'm looking at the ends, if the degree is odd, just generally odd, it could be x to the 11th power even. Any odd power, x to the 7th power, x cubed. The ends are going to be different directions. So like one's going to go up and one's going to go down, or vice versa. If the degree is even, just giving you some general things, so x squared, x to the 20th, x to the 8th, any of the even numbers, the ends are the same. So they're the same if it's even, and they're different if it's odd. Okay, so let's take a look at one of these here. So estimate the x-intercepts. We're going to start with that one. So if we were looking at this one right here, this is, right now I can say this is an even function. Because both of the ends are going in the same direction. I know that the a is positive because both of the ends are up. So they both go like this. And there are 3 turns. So this is just what I'm gathering from, I don't know what the equation looks like yet, but just based off the graph, 3 turns. So I know it's quartic, which is an x to the 4th power, because remember the power, it's 1 less than the power is the number of turns there are. And how do I know how many turns? Here's 1, 2, 3. And looking at the estimating the x-intercepts, I know there should be 4 of them, right? Because it's to the 4th power, so I've got 1, 2, 3, 4. So the first one is going to be right here, -5. The second one is going to be right here, which is 4. And then the other 2 we will find soon, not right now. But these ones could either be a double root, we're going to use synthetic division for this, or a non-real or imaginary or complex, another name for it, root. So either one. And okay, so we did all of what it said here. So it said state whether the leading coefficient is positive or negative, determine whether it's quartic or cubic, and then approximate the y-intercept. So if I look at the y-intercept right here, I could just approximate it, and I'm going to write it as an ordered pair because it's a point. 0, -2, I'm going to guess it to be. And I've done that one. All right, so let's take a look at the next one here. Estimate the x-intercept. We're doing the same thing. X-intercept, positive or negative, quartic, cubic, and the y-intercept. So this is, we know because the ends are different, we know that this is an odd function. Because the ends are opposite. We know that the a is positive because it's going, however it does this, it's going up because of that right there. As we go to the right, it's going up. So we know that. We know there are 4 turns. Here's 1, 2, 3, 4. So it's an x to the 5th power, which is quintic, but this should actually determine I need to fix that. It's not cubic or quartic. It's actually to the 5th power. And x-intercepts are going to be -5, -1, 2, 5, and we're expecting one more because the number of zeros or solutions should be 5. So this one here is going to be either a double root or non-real. And then the y-intercept is approximately 0, -3, I'm going to call it. Okay, moving right along. I know I'm at 10 minutes right now, so I'm going to try to work through this as best I can, quickly as I can. So estimate the x-intercept. So on this one right here, if we just had to estimate, state whether it's positive or negative, going through all these things again, I would say this is an even function because the both ends go to the same way. I would say it's a -a because the ends are going down, not up. There are 3 turns. So this is going to be, there's my 3 turns. So this is going to be an x to the 4th quartic. And that's all I'm going to do on this one. Just making sure that you're able to do that. Let's move to the next one. Okay, so the next part here I'm going to do is sketching a graph without a calculator. So we haven't used a calculator at all on these. State the degree and the leading coefficient of this. Okay, so state the degree and the leading coefficient. So the degree would be to the 4th power. And the leading coefficient is going to be -5. We know this is an even function. We know that, which means the ends are the same, right? We know there are 3 turns because it's 1 less than the function. We know that it's a -a, so the ends are down. And we know there are 4 solutions. That could look like a lot of different things, but if I were just going to sketch this graph, I could sketch it like this. I'm going to sketch out a couple. So it could look like this. It could look like, let's see, I have 3 turns, so it could look like this. Could look like this. Notice how similar they all are. Could look like, I'll do one more here. That. So if I'm looking at the blue, it has to have 4 solutions. So I've got 1, 2, 3, 4. So that would have 4 real solutions. If I looked at the red, 1, 2, that would have 2 real and 2 not real. The green has 4 solutions. The purple here has 2 solutions. So this one here would have 2 real solutions and 2 non-real. So just looking at what the solutions would look like. Okay, let's take a look at this next one here. So state the degree and the leading coefficient and describe the end behavior. So the degree would be to the 3rd degree. Leading coefficient would be 3. So we know on this one, keeping it similar to the last one that we just did, it is an odd function. So we know that the ends are different. We know it has 2 turns, 1 less than the degree. We know the A is positive. So being the A is positive, it's going to look like that. And we know it has 3 solutions. So I'm just going to draw 1 on this one. One possibility would be this one right here. This one right here has 1 real solution and 2 non-real solutions. Notice it has 2 turns, like I said, right here, and the end behavior looks right. Okay, next one. Sketch a graph of any cubic polynomial function that has a negative leading coefficient and one x-intercept. So this is going to be a negative, and it's going to be a cubic function. And so it has one x-intercept, which means it has two non-real numbers. So it's only going to cross the x-axis once. So if I were to do that, you could make that look like this. So it's negative, the ends are going in opposite direction. It's going to negative infinity on the right side. Here's my one x-intercept. And it can look anything similar to this with those characteristics. Sketch a graph of any polynomial function that has a degree of 4, a positive leading coefficient, and two x-intercepts. So this is going to be a positive x to the 4th. So it has two x-intercepts, positive, which means both ends are going up, and two x-intercepts. So it could look something like this. Remember, a degree of 4 has 3 turns. 1, 2, 3 has this one here. They wanted to have two x-intercepts. So you could not have this because this has 4 x-intercepts. So it could not look like that. So be careful on these graphs here. Sketch a graph of a polynomial function that has a degree of 3, a positive leading coefficient, and 3 x-intercepts. So positive, which means it's going to, the end behavior is going to look like that. And if I was going to do that one, and it wants 3 x-intercepts. And here are my x-intercepts. Next one, sketch a cubic function again with a negative coefficient and 3 x-intercepts. So a negative with 3 x-intercepts. So when the a is negative, and here's my 3 x-intercepts. We have 2 problems left. This next one is graphing this equation on a window that shows the local min and max and identifying the coordinates of the local min and max. So you're going to put this right here in your graphing calculator. And let me find mine here. So go ahead and do that right now. Pull mine up here. So I would go into my y equal, and let me expand this out. Oops. So this is going to be x to the 4th minus 8x squared. And I'm just going to do a zoom 6 just to make sure my graph is centered. See what shows up. I know what I'm looking for. I'm looking for like a W kind of, which is right there. But notice I can't see the minimums on here, so I need to make my y negative a little bit lower. So I'm going to go into my window over here. I'm going to go to my y negative. I'm going to say negative 20 just to make that a little bit deeper. And here's my new graph, and I can see my 2 minimums right here and my maximum right here. So now I'm going to calculate. I'll do my minimums first, and it says left bound, so I'm going to go over a little far. Push enter, and it says right bound, so I'm going to go this way. This is something you should already know what you're doing. Enter. I don't want to guess. So my first one is negative 2, negative 16. I'm going to calculate my second one, so I'm going to calculate the other minimum, and I got to move over so I'm by it. So there's my left bound. Move it over again. There's my right bound, enter. So that's going to be 2, because if I rounded that, to negative 16. And then I'm going to calculate my maximum. And I need to get to the left of my maximum. There's the left of that maximum. And then I need to go to the right of it. I don't want to guess. So my maximum, remember 8.20 e to the negative 8, that means this is going to go over here 7 places. So this is going to round to 0. And this is going to go to the left 14 places. So we're going to round this to 0 also. So that would be 0, 0. So when I go back to this, I'm going to go ahead and draw that graph on here. And if I were drawing that on here, it would look like that. And here's my minimums, here's my maximum. So this would be negative 2, negative 16. This is going to be negative 16. And this is going to be 0, 0. I'm going to say be careful not asking for zeros. So I know that that's a 0, that's a 0, and that's a 0, but it's not asking for the zeros. So identify the coordinates, which we already did, and we're moving on to our last problem for the 6.1 section. So 43, the number of homicides per 100,000 people is given by that equation right there. Sorry, that starts right there. Where x is the number of years after 1990. Graph the function on a window with values of x representing years from 1990, which would be year 0 to 2009, which is year 19. And we're going to be really careful on the graphing part on this one. And when you graph that, go ahead and graph that. I'll show you mine in just a second, so you can just pause the video if you want right now. So this was I put that in the y equals. Be really careful. I made mistakes several times doing this one. And there's my graph. I need to fix this window because I wanted the x between 0 and 19. So if I change that part alone, and this should go off the screen, so I need to fix that too. Notice it doesn't, you can't see the end part there, so I'm going to fix my x, or my y minimum could be like negative 5. Let's see if that, oops. Okay, so I adjusted my windows so I could see what this graph looks like, and notice that it's high here, and then it goes down, and then it comes back up. So there's a max in here, and then it comes back down, and it would come back down here. You can't see that part because it didn't want us to show it. So graph the function. There it is. You want to put that on your paper. What does this model give you as the number of homicides per 100,000? I'm doing the B part of this. So if let's just get this in here. So, oops. It's going to look something like that. So what does this model give as a number of homicides per 100,000 in 2009? And 2009 is when x equals 19. So I could go back to my graph, and I could calculate a value where x is 19, and that's going to be 4.945856 homicides per 100 people. So that's what I'm going to write here. 4.946 homicides per 100,000 people. Always have words on that with your number. Use this model and technology, I'm on number C, or letter C, to estimate the year after 2000 in which the number of homicides was the maximum. So the maximum the year after 2000, this is 1990, so I need to look at our, this is x equals 0, and about here is where x is 10, and over here is where x equals 19. So after 2000 would be after year 10. So between here, where is the max? And the max would be right here. So that's what we need to find on our graphing calculator. So I'm going to calculate a max. And I'm going to move that over. And I'm saying the max is right about here. So I'm going to move it to the left, make sure I'm to the left. So it's off that top part there. Enter. I'm going to go to the right of it. There's a lot of numbers in there. Enter, enter. And here's my max right there, which is 16. So that would be the year. So noticing that 16, I'm going to go back to here. That's when X, the year, is 16. So I'm going to take my year 0, which is right there. 1990 plus 16 is going to give me 2006. That's my answer for that one. And D, last one. For what year can we be certain that the model is not valid and why? So I would say, to answer that question, well, it'd be on this side, so before 1990. And then over here, actually, this ends up to be, if I were to bring that down, this is x equals 22. Put it up here. So I would say after 2012, because if I did 1990 plus 22, that is 2012, and that is where it's zeroing out. So where is it invalid? Before 1990, because that's a negative year, and after 2012, because it's also negative. All right. I am not going to move into that section here. I'm going to go right to this page here. So this right here is your homework. I will be setting up a schedule when your homework is due. I've done this video ahead of that time, so you will have time to be working on this homework, so I would get started on this. Use my notes so that you know what is expected. Some of you are kind of lackadaisical on your homework where there's not work, there's just answers, or I can tell you skip some, or you didn't really know what you're doing, and you will get docked on that for homework. So you can go on the solutions online, which I have on my Schoology page, to kind of see things. So a lot of the graphs are already there for you so you can see. But your homework has to have your name, full name, has to be the section with the numbers, and period, whatever your period is, has to have these 3 things on your paper that I can visually see before you upload this assignment. And then you will get credit for your notes that you just took. So you're going to upload those again. Be sure that it says 6.1 on it. You're going to get you're going to get credit for your homework 6.1, and then we're going to have a quiz 6.1. So that's going to be kind of the order of the 3 things. Again, these are going to be worth a little bit more than you're thinking. All right, thank you. Last thing I want to say, I'm at 30 minutes for my video. That would be very good that I can stick within 30 minutes into a 30-minute video for your, so this would be your one-day thing as you're taking notes. Day 1, and then day 2, you're going to be doing your homework, possibly another day, and then the next day, 3 or 4, you're going to be taking a quiz on this. And I'm at 29 minutes, 46 seconds, so that's just where I want to be. Thank you.